The next problem I'll be working is letter U. Chlorine gas is bubbled into a cold dilute solution of potassium hydroxide. And the element that is undergoing oxidation and what element is undergoing reduction. So we're getting insight into a redox reaction. In the letter U, chlorine gas will start out as Cl2. The dilute solution of potassium hydroxide, I'm going to choose to just drop the potassium ion. We are learning that any alkali metal that's a first family metal ion will always, 100% always, be a spectator ion. So let's just work to eliminate that. Chlorine will be starting with a 0 overall for its oxidation number, and we have to show somehow that it's being oxidized and reduced. So when I think about chlorine going to its most common ion, I would end up with chloride, ClO or Cl negative 1. And then the most common polyatomic ion that it will carry is called the hypochlorite ion, ClO carrying a -1 charge. And then thinking about the balancing of the hydrogens, we know that we need to add water to balance those out. So we'll end up with our formula where Cl2 with 2 units of hydroxide, OH negative, goes to form hypochlorite, ClO negative, chloride, Cl negative, and a water molecule is added to balance. Knowing that in this particular reaction, chloride went from a 0 to a -1, there is the GR, and chlorine went from a 0, now remember this is a -2 on oxygen, adding to a -1 overall gives me a +1 on the hypochlorite chlorine in there. So I can show that it has been oxidized, and that's the LEO portion of that. So chlorine is being reduced to a -1 and also being oxidized to a +1 in ClO negative. And that's the answer to your question. Chlorine is being reduced. And that's from the Cl2 to the Cl -1. And it is also being oxidized in that hypochlorite ion, ClO -1, again going from a 0 up to a +1.